Hey guys, welcome back. Some time ago I bought 6 of these boost converters from Banggood and was very unlucky as none of them worked right away. I made a video in which I tried to fix them and I was able to revive 3 out of 6. A link to this video will be top right and in the video description. However, I asked myself if I was right about being unlucky or if there is a bigger problem on hand. And as I also need some more of them for future projects, I bought another 5, so let's see how it goes. Alright, everything's prepared. I attached some copper wire to all of the pads so we can test. The initial test will be just hooking them up to my bench power supply and measuring the voltage with my multimeter to see if they actually work. And if this is done, we then go ahead and use my DC electronics load to see what the limit of one of these boost converters is. So let's go ahead, and I do have these cables over here. Now these come from my bench power supply. I will tell you the voltage going in, the current going in, and you will see what the voltage is. Now let's see. The voltage range is, if I remember correctly, up to 28 volt input voltage. We can get 32 volt output. Let's just go for initially 12 volt and 3 amp current limit. So we're in. Let's see the voltage. 12 volt going in, no current obviously, and we're currently boosting. Now this is very good because you can't probably see. Yeah, that's better. So the first time I bought them, none of them had any output voltage whatsoever, and I just lost output voltage. What is happening? Let me see. Is it one of the connections? No. Now this is interesting. What happened? No. Now that's interesting. There was no current going in, and we are not shorted, but I don't have an output voltage. Let me just grab my test leads and double check. Voltage on input side is 12 volt. It's minus 12 volt because I'm on the opposite pads, and output voltage is non-existent. Do we have a voltage drop across the diode? Yes, we have. We have a 2.9 volt voltage drop. That seems a bit high. What is happening? Let's see. No voltage drop here. That's okay. Let me just turn off the power supply. No voltage on the pads. That's really odd because it did work. I was just pressing down on here. Let's see. Turn it back on. No voltage. It's not shorted. What is happening? I was just moving these clips and suddenly we do have an output voltage. Now, here's one thing. Okay, I was pressing down, and you may think, okay, something shorted underneath, but there's nothing underneath, and this is a silicone tabletop. It can't short. What's going on? Does this? Yeah, something seems not to be connected properly. Okay, this is a bit difficult, but let's just do it like this. If I now press down onto the diode, no, nothing. The pot, nothing. Yeah, what? The inductor seems to have some problem. If I press on the inductor, voltages change. It appears that reflowing the solder actually made it worse. And again, we are not shorted. But now, even pressing down does not change the output voltage. It's at 0 volts. We are at... Yeah, right. The moment I move the multimeter into the picture, it works again. Yeah, sure. What a joke. Okay, it works. Let me see. Okay, it works. Nothing changes. Let me test the other components. Just randomly press down. No, everything works. Yeah, right. The exact moment I move the multimeter into the picture, the voltage is present. That's, yeah, sure, why not? Okay, now that it seems it somewhat works, but not really reliable, because if I... No, alright. Again, I was just moving the multimeter and it jumped again in voltage, so let's see. Now, 12 volt going in, no current. The multimeter only displays current of minimum of 10 milliamps, so there might, or rather there is current going in, but not a displayable amount. Okay, now we turn down. Let's see what the maximum voltage is. So either it was 32 volt, 30 volt, or 28. I think it was 32, but I could be wrong on that. It's 30 volt, so I was wrong. It's 30 volt and not 32. Let's turn it down to... let's go to 24 volt. And now that this is working, this will be the test one, the test unit that I will test with the electronics load. However, first let's see if the other boost converters have the same problem, or if they actually work. Now this one was somewhat working, but not reliable. It appears to be an issue with the choke in this case. Okay, now the next one. I should turn off the voltage. Now I'm turning it on. And nothing. Right. Is it a problem with the choke? No. Random numbers appear while pressing down. Let's see. If I turn it down all the way. Yes. Right. Okay. Now that just happened. Oh, that's the magic smoke. Alright. Very interesting. I thought I was turning down the voltage and not turning up. So let's see. This was set to 24 volt. What is happening? 12 volt going in. 12 volt coming out. Why? What is happening? I thought this might be a quick video, but it appears to be a bigger issue on hand, so yeah. I'm completely lost, to be honest. I don't know what's going on. Let's turn this one on with 12 volt going in, 13.2 volt coming out. Pressing down does nothing. Very good. Not even the slightest variation. Let's turn it to... let's go to 24 volt. So it is at 24.09 volt. So let's turn it off. And let's turn it back on and see. It does work. So one is okay. Yeah, so one thing that I have to do, one thing I always do, the ones that do not work, get an X. Yeah, this one is fried. And this one gets a dot for later inspection. So one is working, so far at least. It appears to be okay. Let's replace it with the next one. Yeah, so it's so weird that one just immediately... oh yeah, right, something I wanted to see. I have to do it with the one that is alright. Maybe I should mark this one with OK. OK. Alright, so what I wanted to test originally with this one, when we just figured out that it doesn't work, was in which direction do I have to turn to get to low voltage. And it is, yes indeed, in this direction. So it's clockwise. Yes, right. So turning clockwise we get to low voltage. That's what I tried to do with the one that got fried. I turned clockwise to go to the lower range. The question is, what happened? Now what I could think of was that the potentiometer was turned so far up, or in the wrong direction. I don't know if this is the direction that turns up the resistance, that by going down at some point the output voltage may have exceeded the voltage limit for the feedback pin, and that fried the chip. But we do have, at least this small resistor over here should be the protection resistor for the feedback pin. Because, so you have two different setups. You either use the potentiometer as a potential divider or as a simple variable resistor, and that whatever you try to do goes to the feedback pin. But you always need a resistor between your feedback pin and your potentiometer, so that in the event of the potentiometer failing, the feedback pin is protected and it just gives out the maximum voltage. Does it make sense? Yes, it does. I think I'm not wrong on this, because that's how most of the time they are set up. I don't know why it got fried. It shouldn't have. So maybe there's a bigger issue on hand, I don't know. Okay, so this one's working. I now know turning clockwise, it does turn down the voltage. Turning it down, voltage goes down. Turning it up, and the voltage goes up. Very, very good. So 3 out of 5 working. I really thought I was just very unlucky, and that normally does not happen. But today, yes, 3 are working, but 2 are not. 1 destroyed itself, although it shouldn't have, and 1 is questionable. I don't know what I can do with it, because what can I do? Re-solder everything? Honestly, I think they are garbage. I cannot recommend them. These are the boost converters you can get from Banggood. I now bought 11 of them. 3 worked right away, 5 not working, and 3 I had to fix myself. So I can't recommend them. Don't buy them. It's not worth it. I hope you liked this video, and if you did, please leave a like. Comment down below what you think about them. And other than that, thanks for watching, and see you next time. Bye!